Have you ever just looked at a map of India and wondered how? How can one single country have literally everything? You've got towering snow-capped mountains, vast fertile plains, ancient rocky highlands, and tropical coastlines. Well, today, we're going to uncover the epic geological story behind it all. This is the story of a landscape quite literally forged by titans. I mean, just look at this view from space. It's an incredible patchwork quilt of geography. You can see that snowy crown of the Himalayas up north, the huge stretch of green river plains right below them, and then that ancient, rocky heart of the southern peninsula. It really is like several different worlds all packed into one landmass. So how on earth did this happen? Well, the answer is a story of immense power, played out over millions and millions of years.
To really understand how India looks today, we have to travel deep into the past. Our story starts with something truly planet-altering, a colossal collision of continents.
You see, over 200 million years ago, India wasn't where it is now. Not even close. It was actually nestled way down in the southern hemisphere, part of this gigantic supercontinent called Gondwana. Just try to picture it. All of these modern continents we know, all locked together like one giant puzzle piece. Then, the Earth's tectonic plates started to move. Gondwana shattered, and the piece that would one day become India broke off and began this long, lonely journey northward. For millions of years, it just drifted across an ancient sea, until, finally, it slammed right into the massive Eurasian plate. And listen, this was not a gentle bump. We're talking about a collision of almost unimaginable force. The best way to think about it is like two giant cars crashing in super slow motion. The smaller Indian plate buckled and shoved against the much bigger Eurasian plate, and all the land caught in between had nowhere to go but up. And that colossal crumpling, that massive uplift, gave birth to the most dramatic feature on our entire planet, the spectacular Himalayan mountain range, India's crown. And what an incredible sight they are. But here's something you might not know. The Himalayas aren't just one single wall of mountains. Nope. They're actually a complex system of three distinct parallel ranges that stretch in this massive arc for 2,400 kilometers. Let's break that down. Think of it like three giant steps. Furthest to the north, you have the Greater Himalayas, also called the Himadri. These are the absolute giants, the big ones, permanently covered in snow. Then you step down to the south, into the Lesser Himalayas, or the Himachal. It's a bit more rugged, but this is where you find those famous beautiful valleys. And finally, you reach the Outer Himalayas, the Shivaliks, which are basically the foothills, built from all the debris and sediment washing down from the giants behind them. And just to give you a sense of scale here, the average height of those Greater Himalayas is a staggering 6,000 meters. Let that sink in. That's the average. This is, without a doubt, the roof of the world. This shot right here brilliantly illustrates the power of these mountains. You see, they act as this massive climate barrier. On the southern side, the Indian side, they trap all the monsoon clouds, which creates these lush green valleys. But on the northern side, they block that moisture, creating what's called a rain shadow. The result? The cold, high-altitude desert of the Tibetan Plateau. I mean, look at that. Two completely different worlds, right next to each other. But the creation of these massive mountains had another equally important consequence. As the Himalayas rose up, they gave birth to something totally different at their feet. The vast, incredibly fertile plains of northern India. And that's the key thing to remember. These plains are a direct gift from the mountains. For millions and millions of years, mighty rivers like the Indus, the Ganga, and the Brahmaputra have been flowing down from the Himalayas, carrying enormous amounts of fine silt and sediment with them. So here's basically how it worked. Imagine these rivers, full of rich soil from the brand new mountains, flowing down into this huge basin or depression at the foot of the Himalayas. And they just kept dumping that soil, layer after layer, for millennia. Eventually, this process completely filled the basin, creating the incredibly deep and fertile land we now call the Indo-Gangetic Plain. And this isn't just some abstract geology, you know? It has a profound human impact. This incredibly rich soil is the reason that civilizations have been able to thrive here for thousands of years. It's what supports one of the most densely populated regions on the entire planet. So, the Himalayas were the dramatic newcomers, born from the big collision. But what about the other player in this cosmic crash? That would be the ancient landmass that the Indian plate itself was made of.
the Peninsular Plateau. This plateau is that original piece of Gondwana. It's one of the oldest, most stable blocks of land on the planet, made of really hard, ancient, crystalline rock. It's a total contrast to the young, still-growing Himalayas. Now, this huge tableland isn't just flat at its edges. It's actually flanked by two mountain ranges that run down the coasts like a set of massive railings, the Western Ghats on the west and the Eastern Ghats on the east. And what's really interesting is that these two coastal ranges are surprisingly different from each other. Over on the left, the Western Ghats are taller, and they form this continuous wall. They basically act like a dam, forcing most of the plateau's big rivers to flow east. But then on the right, the Eastern Ghats are lower, and they're broken up into pieces, worn down by those very same rivers as they finally make their way to the sea. Okay, so we've got the mountains, the plains, and the plateau. But that's still not the whole story. This incredible geological history gave rise to even more diverse landscapes. Let's just take a quick tour, shall we? Head out to the west, and you've got the Great Indian Desert, also known as the Thar Desert, a totally arid landscape of rolling sand plains and rocky outcrops, all shaped by wind and a serious lack of rain. Then you can travel all the way over to the eastern coast, where those big rivers finally meet the sea. And here you find the Sundarbans, the largest mangrove forest in the entire world. It's this tangled, watery world that could not be more different from the desert. And the variety doesn't even stop at the coastline. Way out in the Arabian Sea, the Lakshadweep Islands are something else entirely. They aren't volcanic rock or pieces of the continent. They're atolls, beautiful rings of land built up over millennia by the skeletons of tiny coral animals. So there you have it, the world's highest mountains, some of its most fertile plains, an ancient rocky plateau, a vast desert, lush coastlines, and even coral islands. All of this incredible diversity, every single bit of it, can be traced back to that one single epic collision millions and millions of years ago.
It's an absolutely incredible story of geological forces, but it really leads to an even bigger question, doesn't it? This landscape was born from a continental collision, sure, but how does its ancient geography, the rivers it created, the soil it deposited, the barriers it raised, how does all that continue to shape the climate, the culture, and the everyday lives of over 1 billion people today?